Okay, so moving right along from where we left off in talking about the test statistic being 54.81. The p-value is 2 times 10 to the negative 16. Um, because well, let's do a little bit of this. So SSB plus SSW. So this whole table, let me just jump it and not make it so crazy. So this whole table is used to find the F statistic. And the F statistic, the F ratio, many ways of saying the same thing. There's another way of saying it. The test statistic is used to find the p-value. And the p-value tells you the amount of evidence against the null hypothesis. Okay? So again, this is called ANOVA, one-way ANOVA. So it's the ANOVA. That's why it's called ANOVA. The SSB, what that represents is how far does the sample means deviate from one another. One could argue. And then the within, sum of squares within, is how far does each value deviate from its group's mean. Okay? That's what it means. And then SS total is just the total amount of variability within our sample. So let me even write that just so that you can have it. SST is the amount of variability in the sample. Okay? What that means, truthfully, is how far does each value deviate from the overall mean? How far does each value deviate from the overall mean? Okay. So here you have SST is equal to SSB plus SSW. Okay, DFB, DFW are as follows. K represents the number of levels, and N represents the sample size, and you work out the math. This is nice quiz material, but because of time, I'm not going to be crazy. I'm not stupid. I won't assess you on this. This is easy stuff to assess you on, but I won't assess you on it. I just really want you to know the F statistic and the p-value. Okay, that's that. With that being said, let's move on. Are the observations within each group independent from one another? I would say yes, because again, those people that are posting those posts, I would argue, would not be the same person. Do all groups have the same variance? Oh no. How do you check that? If you look at the group's variances, one is 2,212. The other one, the smallest one, is 295. So they are not the same. And so, what we could say is we can say that the variances are not the same. Does the distribution of the residuals follow a normal distribution? One could say, based on those QQ lines, yes, in a way. Was the data randomly selected? Not really, because they were done in a row. So these are the assumptions. These 4 questions are referring to the assumptions for one-way ANOVA. Okay. Yeah. So are assumptions independent? Do all groups? Yeah, it's definitely validated. Distribution of residual follow each element. 4th is validated because, again, who knows when they posted. The way I'm collecting the data is not random. It's not. Okay, so was the example observational study or an experiment? This is observational because we're not manipulating anything. How do you know this? Right conclusion. So then this is the conclusion. With a sample size of 80, posed 20 from each, we decided to reject the null hypothesis that the population means are the same. One could argue that variability, well, I'm not going to say that, but the test statistic means so large and not concluded that the p-value is so small, so we have extreme evidence against the null hypothesis. So what is the post hoc method? So this whole jazz right here in the output, we did not discuss, okay? There's a reason for this, okay? So the post hoc method is used only when you reject the null hypothesis for one-way ANOVA. Let me say that again slower. You use the post hoc method, in particular, this particular one, it's called Tukey's HSD, allows us to determine which of the sample means are different from one another. And you would only do this, so this is the repeat, you would only do this when you reject the null hypothesis for one-way ANOVA. Since we rejected the null hypothesis for one-way ANOVA because this p-value, we will then use the post hoc method to determine which of the sample means are different from one another. So you remember when I did that 4 times 3 divided by 2? That tells me all the possible pairs. And so this tells me all the possible combinations that I would want to see which pair are different from one another. So this first line denotes the difference between Cal Poly ASI and Cal Poly. This is just the difference. So this is 4,461 minus 354 minus 4,461, and we get negative 4,106.7. This then creates an interval of plausible values for that difference. Okay, this is essentially a pooled t-test. Remember that? And you can see that 0 is not within it, indicating that it's not plausible for the data. It's not plausible for the population means to be equal to 0 based on the data, implying that based on the data, there's no difference between the population. There is a difference. Sorry, there is a difference. You can rewind that one. There is a difference between the population means. And then this is just an adjusted p-value if you were to do a hypothesis test and see that the p-value is 0, so you would reject the null hypothesis that they are the same. So that's done 6 times. That's 4 times 3, 12, divided by 2, 6. It's done 6 times for all the different groups. Okay? And so here, there is a difference between ASI and baseball. There is a difference between baseball and Cal Poly. Sorry, Cal Poly and ASI, Cal Poly and baseball, Cal Poly and football. And that's it. So these are the only ones that are different, these 3. Whereas ASI and baseball, ASI and football, and baseball and football, they're the same based on the data. Okay? So that's how you would interpret this post hoc method. So let's write out a conclusion. I think that's what question 9 is going to be, or related to question 8. Question 9. All right, so what is a post hoc method? Post hoc method is done after one-way ANOVA, after you reject the null hypothesis for one-way ANOVA. Which post hoc method are we using? The Tukey's HSD. When should it be done? When should it be used in terms of our decision about the null hypothesis? It's only when we reject the null hypothesis. Only when we reject H. Okay. Write a conclusion about the null hypothesis. So then here we go. Based on the data, we found that there is evidence that CP, Cal Poly population mean of likes on the post, is different from the other 3, ASI, Facebook, and baseball. Whereas there's no evidence that the population mean of likes for the other ASI, FB, and BSE, football and baseball, are different. That's just saying that football, ASI, and baseball are not different, whereas compared to Cal Poly's Instagram account, there is a difference in likes. Okay? How hard was that? You should tell me. Oh, wow. Oh, okay, so that's good. So that's good. All right, so with that being said, good work. The last part of the notes is a review. Let me know in the comments if you wanted the answers to this review. Okay, that's how I increase engagement. Make sure that you all are participating. So let me know. I'll put this in your questions, and if you want to, I'll put this in your note sheet. If you want the answers, put something in the comments. And I'm looking at the comments, by the way. And then there's finally the glossary. Okay, good. All right, thank you all, and have a good day.